Distance from 0, good.
Distance from the origin.
So when we're dealing with absolute value, we're talking about distance from 0, distance from the origin. Now, when you're measuring distances, you do not measure negative distance. You don't take miles off of your car in reverse. If I walk backwards, I'm still walking backwards 3 feet. I'm not going negative 3 feet. If I'm digging a hole, I'm just digging a hole. It's not going negative. Okay? So the idea here is what we do is called absolute value. Now, the way I like to show how absolute value graphs work kind of goes with the same way that you guys all learn how all graphs work. We like to use tables. Okay? Now, when you first learn how to do tables, when you're dealing with graphs and stuff, we always pick values of x for the domain to input to the function or whatever to get values in the range of your y. So we chose easy values. Usually we chose values on either side of the axis so we know what was happening both positive and negatively. So I always chose this as -2, -1, 0, and 2. I always pick easy numbers. Numbers that make sense. I input and it generates my output. Okay? Now I know this is a little bit easier than most of you. So it's not a big deal, but it's just getting us the idea of how this works. What's the absolute value of -2? 2. Absolute value of -1? 1. Absolute value of 0? 0. Absolute value of 1? 1. And 2. Okay. Now your input-outputs generate ordered pairs. I know. So you start plotting some stuff. We got -2 and 2, 1 and 1, 0, 0, 1, 1, 2, 2, and you get this generic shape. Okay? Absolute values will all have the same generic shape. They'll all look like some sort of a V. Depending upon what some of the actual equation itself looks like, or the function itself looks like, each one of them might have something funky going on. Yes, sir?
Basically, what would happen is you just put everything under everything with the y value is negative, and you just flip it upside down.
It's kind of almost like an inverse. Yes, kind of. All right. Same idea. If I wanted to get a little even crazier with this, and I need to put things together in terms of order of operations. So this says -2 times the absolute value of x. When you're dealing with absolute value, we're doing the same idea of this direct substitution via a table. You're still kind of doing the same thing. We're still we're picking our own input. We're taking this and what's happening here is, oops, I always get a habit of making them parentheses by mistake. As you start generating and using your table stuff with this, the absolute value function stuff, those uprights, when you're doing order of operations, treat those like you would have parentheses. The absolute value symbols they're still kind of like a grouping symbol. So it tells you to take an order of operations would tell you to take the absolute value of 2 first, and then multiply it by -2. Okay, that's what that says. What's the absolute value of -2? 2. What's 2 times -2? -4. Okay. Generating ordered pairs. Absolute value of -1. 1 times -2. Okay. What is it? -0. There's such a thing as -0.
No.
0 it has no value. Good, and great. What's the absolute value of 1? What's 1 times negative 2? And then, obviously, right? Now, when you go through this one, you'll notice something else different occurred. What changed?
It flipped.
Why did it flip? Yeah. What happens here is that there's this multiplier out front. This multiplier out front is what we're going to call an A value. This value of A determines whether it's the absolute value function is going to open upward or downward. If it's positive, it opens up. If it's negative, it opens down. You've actually dealt with this A value before when you guys learned about quadratic stuff a couple years ago. Okay? Yes, sir? No. If it opened sideways, it would no longer cease to be a function, because then when you had a value of x here, it has 2 values in the range, and that can't happen. I mean, we could graph it, but it's not a function, so it wouldn't be an absolute value function. Yes, sir? Ordered pairs. How do you graph anything if you're not sure how to graph something? No, you use ordered pairs. We're making tables. Yeah. Remember when you first learned how to graph lines? You picked points. You substitute in, and you got an output. You picked your input to generate the output. You put your domain to get the range. Pick an x, get a y. Okay. So the idea here is, you guys did this when you learned about quadratics a couple years ago. If your A value was positive, you knew it was up like a cup. If your A value was negative, it was down like a frown. Same basic principle. A value tells you direction. Okay? In this case, our A value also tells us direction. But this A value has a lot of other stuff. So what happens here is that this becomes your introduction to what we call A, H, and K. All of our graphs that we deal with in Algebra 2 have what's called a parent function and a shifted function. This shift means that there's some horizontal, left and right. When you move left and right on a graph, it corresponds to which values? X. And when you move vertical, you're moving up and down, which is your y values. So every graph that we deal with, whether it is absolute value, which is linear, eventually we're going to look at quadratic stuff, which is a little bit different. We're going to look at that. We'll eventually get to logarithm stuff, H's and K's. Next semester we'll get to stuff like that as well. Where all of this H's and K just stands for horizontal, moving left and right, and vertical, moving up and down. Yes, sir?
Like how the function sine takes away whatever, and how you, and then H would modify H, and then H would modify like
where it starts, and K tells you how high up, where it's. The H and K is basically where it starts. Okay. So what happens here is we've got this generic form of when we go in with like A, H's, and K's. Your vertex is always going to be at H and K. Now these first two examples we had H and K values of both zeros. That's why our vertices were at the origins. Why our vertex was at 0, 0. What happens now is that if our A value is positive, it's going to be a V that opens upward. If the A value is negative, it's a V that opens downward. Fairly simple. This A value also, if you look at it, if I go back here real quick, what was our slope? Down 2 over 1, down 2 over 1, wasn't it? One of them had a slope of -2, which is your A. The other one had a positive slope of 2. Over here, we had a positive slope of 1. And on the other side, we had a negative slope of 1. So the A value for these guys helps you determine the slope. One of them will be positive, one of them will be negative. Okay? When your slope was 1, it was pretty normal. When your slope was 2, it became steeper, didn't it?
Yeah.
If the slope is 1/3, it would be wider. So the idea is that the larger the absolute the larger the absolute value is than 1, the steeper the slope versus the wider the slope. That's where all that comes into play. Right? Again, those are slope things that you guys knew. So if I'm looking at this problem here, I have 1/2 times the absolute value of x plus 2, all subtract 3. Now remember, the generic form for h's and k's, your vertex lies at hk. So that means it's, excuse me, if it says plus 2, what's my h? Remember the generic form. If the generic form is minus h, and this is plus 2, what's your h? -2. The h value is what is the opposite of that sign. The k value is always the same. That's the weirdness in how it's written. Minus the h just means it's minus -2, which in essence is plus 2. If it was -6, your h would have been 6. That's where that goes from. And honestly, this just takes a little bit of getting used to in order to do this. Believe it or not, you guys have actually you've used this format before without knowing. What's that? Point slope, right? It's point slope form. Where they're telling you the ordered pair is at some x sub 1, y sub 1. Well, if you have an x sub 1, isn't that just some horizontal? And the y is some vertical? So this is the same thing as slope is that value. It tells you if you're going up or you're going down. So it's the same thing as a multiplier. Give me a second. Move that over. Same thing. Yes, sir.
Didn't you already say that last week?
Probably. Just reminding you. It's okay. So let's see here. We had y is 1/2 absolute value x plus 2, all subtract 3. Okay. So if I wanted to graph this, one, all we need to be able to do is, I always love labeling my parts. What's my A? What's my H? What's my K? I do this religiously throughout the entire school year. I always label out my parts because it gets easier the more you write out. The more information you understand what things mean, the easier the math that we do becomes. Okay? So what's your A value here? It's the slope, but what's the value of A according to this equation? 1/2. Is that positive or negative? Positive. So maybe in my mind, right below that, it's absolute value, it's positive, I'll make a B that's opening upward. So if I start graphing something and it's all goofed up, I know that I'm screwing something up. Okay? I do that with quadratics too. If my A value is positive, I make a little U in there because I know it's going to be up like a cup. It's just getting your mindset here. We know our H was -2, our K is -3, which means our vertex is at -2, -3. So, first thing I'm going to plot is what? The vertex. -2, -3. I know this has to be an opening slope. Give me a second. It's got to be a slope of 1/2 to start. if I know it's going to have one of the slopes is going to be positive going up and right, the other one's got to be negative, so it's going to go up and left to create the V. All I do is just start marking off. Up 1 over 2. Oops. There's my V. Yes, sir.
So it's kind of like shifting the origin
That's
HK.
That's all this is.
And then basically drawing the functions between HK
Yeah. Yeah, that's all this is. That's all it is. And as we get into it, it's nice to start with the H and K's with absolute value to introduce you guys where this is coming from, because later on, we plot parent function, and then we plot shift. And then if you plot parent, if you know that there's a horizontal, which means you're moving your x's, and there's a vertical, which means you're moving your y's, you know how to adjust your ordered pairs. So by starting with this horizontal vertical shift with your x and y's now, as we get into things that are more complicated, it becomes a lot easier. Not bad, not too bad. Try this one then. Go ahead and plot that one. So. What's your A, H, and K? A is -1, good. So what direction is this going to go? It's a V going down. And then we've got H is -2, good, and K is 3. So vertex, -2 and 3. Okay. What's that? Yeah, it's continuous. This is continuous. This is the domain for this one would be all real numbers, because whatever value of x you substitute in, you're always going to get a value of y. Your domain is restricted though, okay, and I'll show you that here in a second. So -2, 3, I just plotted, -2, 3. I have a slope of -1, so I know that one of them is just going to go, and then I go the other direction, and I make my V. Like I was saying here, this is not a domain restricted type problem because all real numbers work for it. It does have a boundary as far as the range is concerned. The boundary for the range is always going to be, in this case, your K value. The K value in this, since your A is negative, the K value is the maximum value it could be. So it's going to be all values that are less than, or all values of y that are less than or equal to 3 would be your range. All right, does that make sense? We do domain and range a little bit later on, but it doesn't hurt to start labeling things out now. You'll see that a lot of times with the K value, since K is your vertical component, that usually gives you, since that goes with your range, that usually is your boundary for your range stuff, okay, for a lot of these things. Okay? What? I say it so nicely.
So, I've been thinking about H and K, and then I've come up with circles where the equation of the circle would be
yeah, you guys did that last year. Yes.
Equals x plus the quantity of x minus x plus h
x minus
squared,
minus.
Yep. And plus x.
Yeah, we'll get to conic sections later on, but yes, and this is what you guys. Yeah, you did that. You did that last year. You did that last year in circles. Did you guys do that?
We did do the graph as well.
Okay. Yeah. Circle graphs are stupid easy, so that's why you probably didn't do it.
We did do the equation.
Yeah, but no, you're right. We talk about those things in terms of conics later on, so it's not a big deal. Yep. So when we get into this one of the things that I'm going to have you guys do is I'm going to ask that can you write the actual equation then? So now, when you're looking at these things, it's kind of tough. Let me blow this up a little bit more. All I want you to do is there enough information here for us to be able to write the equation out?
Yes.
Okay. First thing you should notice is that what direction is this going?
Negative.
Then it's moving downwards. So what's your A value going to be?
Negative.
Negative. Good. So what I would do is, first of all, identify where my vertex is. Where do these two graphs change direction? They change direction at 3, 1. Okay. So that means my H and K are 3 and 1 for H and K. I know that my A value has to be negative because it's pointing downward. So I have to figure out my slopes. What I always will do for you guys on any graph that I ask you to write is that you'll notice it's kind of hard to see that there are a couple other dots here. So that way you guys will be able to figure out slopes. You won't have to kind of go guesstimate and say, well, it kind of looks like it goes to that order pair. I will put a definitive dot on something so you won't get tricked. As much as I like to trick you, I won't trick you. Okay? So you just got to count your slope. So let's see, we go 1 little, 2 little, 3 little spots. 1 little, 2 little, 3 little spots. So our slope was 1, but since it's moving downward, that means our A value is negative 1. Good. So your A value is negative 1. So when I put this all back together, we just move this over, I know it's y equals A absolute value x minus h plus k. Well, substitute in negative 1 absolute value x minus 3 plus 1. Yes. Yep. Absolutely. I just wanted to make sure that you saw it was negative 1. If you just put a negative up from the absolute value, that's fine.
You just have to assume that there's only one value.
Well, you don't have to assume it. It is there. Yeah, it's a definitive thing that it is there. It's just left off sometimes. Yeah.
Could you find the exact value?
Just by slope. For these guys, it's slope. Okay. Your slope will always be that one. All right. Your slope will be that. So that'll get us through there. There are other ways to get A values when we get to quadratics, especially when you're in what's called vertex form. But it comes with a whole lot of other algebra. So completing the square stuff, there's values and things that you can get through. Going from here versus your standard form. There's a lot of different little rules and things that'll happen. So, but that's not to worry about yet. That's still a few weeks away as we go through that. Okay. Want to do one more of those? We are.
Yes.
Okay, we'll do one more.
Please.
That looks like a rat's face.
And I can't unsee that now.
Right.
Just one blue line.
It looks like that one ghost dog.
Sand? Is that the sand?
No. Okay. Again, as you're looking at these things, a couple things you're going to identify right away. First thing you go to identify is your A value being positive or negative. In this case, your A value has to be what? Positive. Good. Has to be positive. And then from there, also you can figure out rather quickly where your vertex lies. In this case, our vertex lies at, what's that? -1, -1. Right? What's our slope? Our A value here? 2. Okay? So we have all the info then to be able to put it together. We know our A value is 2. Our H value, -1. Our K value, -1. Put it all together. Remember, -1 being your H value for where the vertex lies, X minus a -1 is how we generate the +1. And that's where that comes from. Oh, happy times. Do those. If you need an extra piece of scrap paper, help yourself. There's still some back there. I think I've got like 3 of each style there. Sorry, 4 of each style. There are 4 graphs and 4 right in the equation. Shouldn't take very long whatsoever. This is absolute values are fairly simple. Tomorrow, what we're going to do is I'm going to try and put together a whole bunch of junk for us to look at. Remind ourselves how slopes work again, and remind ourselves how shading linear inequalities work, and we'll go from there. Okay? Whoa. What's up? I wanted to do this first.